We've all been there. You're driving along, minding your own business, when suddenly, bam, an unexpected problem arises with your car. It's not a pleasant experience. And it highlights just how critical the testing process is when it comes to ensuring that the car you drive is reliable and safe. But did you know that there's a secret blueprint that underpins the testing of every car in the world? A blueprint that guarantees that every brake, every sensor, and every line of code is tested to perfection. It's called the V model, and it could save your life one day. So if you're curious about what goes into making a car safe and reliable, stick around. In this video, we'll break down the V model so simply even a 5-year-old could understand it. Let's go. First things first, what is the V model? Well, the V model stands for verification and validation. The two pillars that guarantee your car doesn't just work, it works safely. On the left side, we've got the planning and design stages. This is where we check what we're building before we even start coding. This includes requirement gathering, system analysis, software design, and model design. These steps are all about verification, making sure the plan matches the customer's needs before we write a single line of code. Next comes the bottom of the V coding. This is where the design turns into actual software. Now, it's time to climb the right side of the V, validation. This is where we test everything we built to make sure it actually works in the real world. We go step by step through unit testing, integration testing, system testing, and acceptance testing. Each step ensures that the software is not just working, it's working right. Now here's a quick breakdown of each stage. First, requirement gathering. This is where we figure out what the customer actually wants. For example, if the customer wants a safer car, that might turn into a requirement for a backup camera. Next, system analysis. Here we translate the big goal of making the car safer into system requirements. For example, the backup camera needs to have a wide field of view and high resolution to see everything behind the car. Then software design. Here we break it down further. For example, the backup camera should be able to automatically detect objects and show them clearly in the video. Finally, model design. This is where we get super detailed. For example, the backup camera should be able to detect pedestrians, cars, and other obstacles and display them with bright colors and clear markings. After the left side of the V, we move on to coding. This is where we actually build the software based on the requirements. Then we come back to the right side of the V for validation. We start with unit testing. This is where we check the tiny building blocks of the software to make sure they work. Next, integration testing. Here we check that those blocks work together as expected. In system testing, we test the entire car's software as one to make sure everything works together perfectly. Last but not least, acceptance testing. This is the final check. Does the whole thing meet the original customer requirements? In this case, does the backup camera work as intended? Remember, verification is before coding. It's about making sure we're building the right thing. Validation is after coding. It's about making sure the thing we built works right. Both are super important, and both are done by a test engineer. So the next time you're in a vehicle, remember, there's a hidden V keeping you safe. From requirement to testing, the V model ensures that your car is not just advanced, it's also incredibly safe. That's a wrap for today. If you love high energy, simple breakdowns of complex engineering topics, subscribe for more updates. We'll catch you in the next one.